Welcome to math classes. Today we'll discuss about the determinants, which is NCERT class 12th chapter 4. Okay, this is a kind of extension of matrices, which we have learned chapter 3, and this is the extension of that one. Okay, so let's get into determinants. Yeah, determinant is basically it's a uh, extension of matrices concept. Okay, it builds on the concept. It's a number, special number associated with a square matrix. Okay. And with this number, okay, since it's called determinant, okay, determines something. Okay, one is checking the uniqueness and solutions of the linear equations, and then also in some of the solutions like area of triangle and several more applications. Okay, it is useful in many ways. Okay, let's take two linear equations, simple linear equations: ax plus by equal to m and cx plus dy equal to n. Okay, when you can solve these two equations. Okay, we know the conditions from the linear algebra. A by C should not be equal to B by D, correct? If both are equal, that means LHS side is same, but for the same equation you have two values, which means it is indeterminate, correct? A by C, ratio of A by C should not be equal to B by D. Okay, if they are equal, then it is one equation you have two values, M and N. Okay, that means X and Y are indeterminate. Okay, so we know that the condition for solving these linear equations is A by C should not be equal to B by D, which means AD minus BC is not equal to 0. Okay, this is called determinant. AD minus BC is called determinant in matrices. Okay. So this is the most important to understand from where actually determinant has come. Okay. If I take in matrix form, okay, example of this one, these equations will translate into these matrices, correct? A, B, C, D, x into y, x, y. Okay, if you multiply these two, basically, which is equal to m comma n. So A into x, B into y, right? Ax plus by equal to m, cx plus dy equal to n. That is what this equation translates to. Correct? Now, I'm trying to tell this determinant should not be equal to 0, AD minus BC. This is called determinant. Okay. Now, this will tell me existence of a solution. Solution is possible or not, it will tell first thing. Okay, and uniqueness of the solution. Okay, these are the two important things which will be determinant. Okay. So determinant is a number associated with the square matrix. For a square matrix, A determinant is denoted by these three ways. Okay, it's like modulus here we call, but this is not the algebraic modulus. Okay, that only positive, right? And modulus means here it means the determinant. Delta of A or delta. Anyway, you can denote it. And remember, most important thing, only square matrix have determinant, and absolute A is not modulus. Okay, in matrices terminology. Now, first order determinant is very simple. In a matrix, we have only one element, so determinant is also same element. Okay. For second order, we already saw that. Okay, if we get A, B, C, D, this is the matrix A, order 2, basically 2 by 2. Determinant is AD minus BC. Okay, this is simple. For a third order matrices, okay, our chapter is limited up to third order, but you can extend this to any order. Okay, third order, okay, we can choose based on any row or any column. So that means you have 3 rows, 3 columns. So 6 ways you can determine the determinant. Okay, you can evaluate the determinant. Okay, all options will give same way. Let's take by row 1. Okay, which is row 1, A11, A12, A13. Okay, based on this we'll determine the, we'll evaluate the determinant. Okay, of this one it is nothing but minus 1 whole to the power of A11, right? I'm taking row 1, so A11, so 1 plus 1, and a determinant of, you leave the row and column. Okay, 1 1, right? I'm in a row 1 column 1, so I'm leaving column 1 row 1. So I have a sub matrix, correct? I have a sub matrix here, A22, A323, A32 and A33. Okay, this determinant, which is nothing but, we know it is nothing but A22 into A33 minus A23 into A32, correct? So multiply with A11 and then positive or negative depend on the row and column number. Okay, so plus minus 1 whole to the power of second one. Okay, second one is minus 1 whole to the power of, this is 1 comma 2, so 1 plus 2 into A12 into, you leave this row, this column, so I am left with A21, A23, A31, A33. Okay, plus minus 1 whole to the power of 1 plus 3 because I am choosing 1 comma 3 now into the remaining determinant of remaining 4 terms. Okay, that is if I a13 then I am left with a21, a22, a31, a32. Okay, so if I simplify, this is what it is exactly. Okay, so the sign positive or negative depends on the which element it is. Okay, the row and column index, it depends purely on that. Okay, so this is my determinant based on row 1. If I take similarly column 1, this is what it will become. You can rewrite. Okay, or if you take any other column, column 2, if you take, this is what it will become. Okay, so this is basically whatever is the index here, row 1 plus column, row plus column basically. Okay, so which one to choose, which row to choose for determinant easily? Okay, the easier way is you choose a row or column where you have maximum number of zeros, which means you don't need to do much, right? Zero you can leave. If that is zero, you can leave that term, right? So that's for the advantage. Okay, so let's do some chapter, simple, very simple chapter based on the basic understanding of determinant. Okay, evaluate the determinant of this value 2, 4, minus 1, minus 5. You know it is 2 into minus 1 minus of 4 into minus 5. Correct? So which is nothing but 18. This is the answer. Okay, this is the very simple basic AD minus BC you will apply. Correct? And evaluate this one. We can do it directly. Cos square theta minus of minus sin square theta, which is cos square theta plus sin square theta, that is 1. Okay, so this is the expression, so you expand it, nothing but x square minus x plus 1 into x plus 1 minus x minus 1 into x plus 1. Okay, so you expand it, you will get x cube minus x square plus x square minus x plus 1 minus x square plus 1, which is simplified x cube minus x square plus 2. Okay, so these are all very simple, and this is very important to know, this third one. Okay, second order matrix, which is A 1 2 4 2, show that determinant of 2A is equal to 4 times determinant of A. Okay, not 2 times. Okay, I am multiplying matrix with a constant 2. Okay, so which means first thing is determinant A determinant is nothing but 1 into 2 minus 4 into 2, which is minus 6. 4 times a determinant of A is minus 24. Okay, now 2A is nothing but 2 times I multiply each element, so 2 4 8 4. Okay, now what is my determinant of 2A? This is nothing but 2 into 4 minus 8 into 4, which is minus 24. So if I am multiplying a matrix with a constant, okay, and matrix is of order 2 by 2, then its determinant is basically that number square. Okay, that constant square multiplied by the determinant of the original matrix. Okay, so this is a very important note. Okay, most of the times you may get questions based on this one. Okay, so note down this one. If the matrix is 3 by 3, like which is shown here, if it is 3 by 3, it will become this constant is 3, so 3 cube, because it's a 3 by 3 matrix, cube you have to do. So 3 cube, which is 27, it will become. It's exactly same as previous problem, so you can do it yourself. Okay, only thing is I'm choosing by column 1 here determinant because I have two zeros here, so I'm interested only in the first one, right? So determinant of A is nothing but 1 into 1 into 4 minus 0. Correct, that is 4. Okay, 27 times 4 is 108. 3a is this value, and again by column I am doing 3a module 3a determinant, which is nothing but 3 times 3 into 12 minus 0, which is 108. Okay, so this is true for our 3 by 3 matrices. You have to do cube of the constant. Okay, evaluate determinant, this is simple. I will definitely choose this column 1. Correct, or row 2. Okay, row 2 is more zeros are there, so by row 2 if I do, this is minus 1 into, and this is which sixth, right? Sixth means it will be positive, so no problem. Yeah, it will be positive, it will be negative actually. This is sorry, 2 comma 3. 2 comma 3 is 2 plus 3, which is 5. Minus 1 whole to the power of 5, so it is minus 1. Correct, so minus. Now if I remove this one, it will become uh, minus, sorry, this is here, minus 1 into 3 into minus 5, that is minus 15, minus of minus 2 into 3, which is plus 3. Minus of, sorry, this one, minus of minus 1 into 3, which is plus 3. Okay, so the determinant is minus 12. Okay, so choose the row or column appropriately. Similar, evaluate, so all numbers are there. It is easy to choose this number, but you can choose anything you want. Okay, so I did by expanding by row 1. Okay, so you can cross check your answers. These are the simple questions, so very simple determinant questions. You can do it yourself. Similar, you can choose maybe row 1 and do it. Okay, because 1 0 is there, so other two, 1 is 0, so ignore it. 1 minus 1 second term, so it is minus 1, 0 minus 6, 2 into minus 3. Okay, so simplifying, I'll get 0. Okay, this is important note actually. If determinant is 0, it's called singular matrix. Okay, now this is another one. You can expand it by column 1 and do it yourself. Okay, here determinant is 0. So note that a matrix with a determinant equal to 0 is called a singular matrix. This is important because sometimes they'll give the matrix is singular. Okay. Now this one is find value of x if these two determinants are given. 2, 4, 5, 1 determinant is equal to 2x, 4, 6x. Simple. You apply the same determinant to 2 into 1 minus 4 into 5. So 2 minus 20, which is equal to 2x square minus 24. Simplify it. You will get x square equal to 3 or x equal to plus or minus root 3. Okay, two values are possible. That note down that one. Okay. Similarly here 2, 3, 4, 5, which is equal to x3, 2x5. So if I simplify, it is 10 minus 12 equal to 5x minus x, or x minus x equal to minus 2, or x equal to 2. Okay, another one. Similarly, you can do x square equal to 36. You will get here x equal to plus or minus 6.
Struggling with Maths Olympiad or Engineering Entrance Prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BITSAT with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BITSAT, we've got you covered, with full NCERT classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/@psk99999 and let's make math your strength.
Let's see one of the applications of the determinants. Okay, area of the triangle. In coordinate geometry, you might already seen what is the area of the triangle using three coordinates, right? If x1, x1, y1, x2, y2, x3, y3 is given, how to find the area of the triangle? You might remember the formula, and some of you are already using determinants to determinant method to find the area. Okay, if not, you can learn it now. Okay, the formula comes from the determinant actually. Okay, so if x1, y1, x2, y2, x3, y3 are vertices of the triangle, then area of the triangle is half of x1, y1, determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, if you expand, this is what you will get. Okay, half of x1 into y2 minus y3. Okay, plus x2 into, because even though it is minus of y1 minus y3, it will become, so y3 minus y1 I am changing to make it plus, so that it is all symmetric. Okay, so x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so this is the formula. Normally you would have remembered this or this change in the terms actually. Okay, but this is how you get the area of the triangle formula. Okay, now note down few things actually. Though it is one simple formula, you can do a lot of things actually. Okay, one is note is if you get a negative value with this equation, okay, make it positive. That means take the modulus of the above value because it is area. Okay. Okay, area formed by three collinear points is 0. So in case you take the determinant and found that area is 0, that means those 3 points are collinear. Okay, now equation of the line joining x1, y1, x2, y2 is Okay, determinant of x1 y1 1, x2 y2 1, xy 1. Okay, what is this means? Means I am assuming xy is another point in the same line, on the same line. Okay, so that means determinant of three points on the same line, collinear points, is 0. Right, now from this expression I can get my equation of the line, because we have two variables here, right? X and y are variables, so you will get equation of the line. Okay, now if two rows and two columns are same in the matrix, the determinant is 0. Okay, suppose row 1 and row 3 are same, then determinant is 0. If column 1 and column 2 are same, then determinant is 0. Okay, so this is one easy way. Okay, how do you prove it? Very simple. You take determinant by the third row here. Here second row means this first row and third row are same, so I am taking the different row. If I take, okay, 2 into, and I have my other uh, values are 1 2 2 1, correct? 1 2 2 1, so I'll get a 0 here. 2 3 2 3, I'll get 0 here. 1 3 1 3, I'll get a 0 here. So you will get determinant 0 if any two rows are same or any two columns are same. Okay, now if a row is added to another row, determinant remains the same, which means if I have a matrix 1 2 3 4, and if I am adding I'm adding 3 to 3 to 1, it becomes 4. 4 to 2, it becomes 6. Now determinant of these two is same. Okay, which is minus 2 4. 4 minus 6, 16 minus 18. 16 minus 18. Okay, both ways it is minus 2. Okay, determinant don't change if you add a row or column to the other row or a column. Okay, so these are the simple, very simple application of determinant. Though you can create multiple types of questions with this. Let's do an exercise and do what kind of questions you can create using this. Okay, so one is simple. Given 3 points, you find the area of the triangle. Okay, which is simple determinant. Half of determinant of those 3 points, and the third column you will take 1 1 1. Correct. So it is 1 0 1 6 0 1 4 3 1. Now determinant, you just expand it, you will get the answer anyway. Okay. Okay. So this is one. Simple 15 by 2, because you get negative value or positive. Okay, but you need to take modulus value, so it is 15 by 2. Similarly, you can do other problems. Okay, second 2 comma 7 1 comma 1 and 10 comma 8, which is exactly same. You can do it yourself, cross check the answer here. Third same, find the 3 points are given, again find it. Okay, so you get 15 here answer. Okay, next. Yeah, second type of problem is instead of numbers, they may give some algebraic equations and then ask you to check if it is area of triangle is some fixed number or they are collinear, like that. So, okay, something here is a comma b plus c, b comma c plus a, c comma a plus b are collinear. You have to prove that. Okay, so collinear condition is determinant should be equal to 0. Correct. So you take determinant directly. Okay, triangle, I mean area of the triangle formed with the 3 points. You need not consider half here because you are looking for 0 answer, right? If it is non-zero, we'll tell it is non-collinear, right? So you expand it, okay, and simplify it here, okay, then summarize it, you will get 0. Okay, so these 3 points are collinear. Okay, not so linear, it's collinear. Find the value of k if the area of the triangle is 4 square units and vertices are k comma 0, 4 comma 0 and 0 comma 2. Okay, this is another kind of simple change in the problem. They give the area, but they will not give the coordinates, all the coordinates. One of the coordinates they will put it as a variable. So same thing, you just expand it same way how you are doing. Area of the triangle is half of modulus, half of determinant. So k01, 401 and 021, okay, which is equal to 4 given. So now you expand it. Okay, when you expand it, you get a equation. Okay, only thing remember, okay, when you are finding a variable in coordinates, okay, you are always getting determinant in modulus form, correct? So when you equate it to a value, okay, and solve that equation, something like here, absolute k minus 4 equal to 4, right? This means very clearly you can say k is 4, k is 8, sorry, okay, but k is 0 also possible, because if I remove the modulus, k minus 4 is equal to plus or minus 4, correct? K minus 4 equal to 4 or minus 4. So you have to take both the values and determine k. K is 0 or 8. Since this is coordinates, k right? This is k comma 0 is a coordinate, so it can be either 0 comma 0 or 8 comma 0. Both the points you get the same area. Okay, this is something like this. You draw 2 points. Okay, third point can be above or below. Both are possible, right? Exactly same vertices, same vertical number. Okay, y coordinate is same, but x coordinate can be above or below. Simple as that, right? So you will get two values. Okay, so remember that when you are solving these problems. Okay. Yeah, this is also exactly same. If find out k, if the area of the triangle is 4 and the coordinates are given minus 2 comma 0, 0 comma 4 and 0 comma k. Same thing you will apply. Half of minus 2 comma 2 0 1 0 4 1 0 k 1, which is equal to 4. So determined by column, because column has more zeros. Here also you get two values for k equal to 0 or 8. Okay, same thing. Okay, next. Find the equation of the line joining 1 comma 2 and 3 comma 6 using determinants. Okay, so this is, we know already, area of, if you assume that x comma y is on the same line, then you take the determinant of these 3 points, which should be equal to 0 because they are collinear, right? So x comma y is another point on the line. So area of the triangle formed by this one is 0. So which means half of determinant is 0. The determinant is formed by points 1 2 1 3 6 1 x y 1. Okay, column 3 is always 1 1 1. Okay, so now you just simplify this one. Okay, so this is 1 into 6 minus y minus 2 into 3 minus x. Okay, plus 1 into 3y minus 6x. I am applying determinant by row 1. Okay, now simplify this further. What you will get is 4x minus 2y, which is equal to 0. Okay, this is the equation of the line. Okay, next. Similar, find the equation of the line joining 3 comma 1 9 comma 3 using determinants. Exactly same. You can do it yourself. Cross check the answer. You will get 2x minus 6y or x minus 3y equal to 0 as the equation of the line. Okay. If the area of the triangle is 35 square units with vertices 2 comma minus 6, 5 comma 4 and 4 k comma 4, then what is the k value? This we have done exactly similar one before. So you take the determinant, half of this determinant is equal to 35 because it's the area of the triangle which is given as 35 square units, right? So now you simple expand, and as I said, when you are finding the coordinate, where variable is in the coordinate, because of absolute modulus value, you will get two values. Okay, so if you simplify it, what you will get is 50 minus 10k. 50 minus 10k equal to plus or minus 70, because you are removing the modulus, you will get other side plus or minus, so plus or minus 70. Okay, now it is simple. 10k equal to either 120 or minus 20, or k is equal to 12 or minus 2. These are the answer. Okay, two values are possible. Okay, let us understand the minors and cofactors of each element in a matrix. Okay, and this will help you to find out the determinant easily, and determinant and also the inverse of a matrix. Okay, so let's understand before going to the inverse. Understand and practice more minors and cofactors. Okay, there is a spelling correction here. Minors and cofactors. Okay, so what is the minor of an element? Minor of an element aij. Okay, you know the notation. Small a ij, if I write it, it means the element ith row jth column. Correct? So now minor of an element aij is obtained by deleting the ith row and deleting the jth column, then determine the remaining matrix. Determinant of the remaining matrix is the minor. Okay, when we see the example, you will understand easily. Okay, so basically from the given matrix, I will remove ith row, I will remove the jth column, and then remaining elements as is I will keep. Okay, so you will have if you are having a 3 by 3 matrix, then the minor you will get is a 2 by 2. Correct, 2 by 2 matrix you will get, only 4 elements you will get. Now determinant of that one is the minor of that a I comma j. Okay, so minor is denoted by capital M I j. Okay, order of a minor is, if the original determinant is n by n, then minor is n minus 1 into n minus 1. Okay, this is what I was explaining. Okay, now next, cofactor. Cofactor of element is just a you basically add a sign in front of minor, then you'll get the cofactor. Okay. Cofactor of element a, small a ij, is denoted by capital A ij, which is nothing but minus 1 whole to the power of I plus j m I j. Okay, that means minor first you calculate, and then you add in front of that minus 1 whole to the power of I plus j. Okay, if I plus j is odd, then you will get minus 1 minor. If I plus j is even, then you get mij is same as aij. Okay, so cofactor is nothing but signed minor, that way, right? Next, determinant and expansion using cofactors. Okay, so now you know you can calculate minor, and then from that you can calculate the cofactor. Correct. Once you have the cofactor of the given matrix, then determinant is nothing but you can take any row or any column. Okay, any row or any column. Okay, and then multiply the element with its cofactor. Okay, and the sum of all the elements in that row or column, then you get the determinant of it. Suppose you take a 3 by 3 matrix. Okay, a I comma 1 into a capital A I comma 1 plus a I comma 2 into capital A I comma 2, that is with its cofactor, a I comma 3 element and its cofactor, multiply with its cofactor, which is a I comma 3 I3, right? Or you can go by column also. Okay, you take the column, 3 columns elements, and the same each element should be multiplied by its own cofactor, and then sum of those either row or column elements. Okay, so that way you will get the determinants. This is the determinant. Okay, now hope you understand this one. So let's do some practice questions, simple practice questions to get the information into your mind. Okay, so one is the orthogonality property is there. What this says is, if you take any row or column elements, okay, take here I took first row elements, that is small a 1 1, okay, a12, a13. Okay, now I am multiplying each of these first row elements with minors of second or third row. Okay, in this case example I showed second row cofactors I took. Okay, that is a11 into capital A21, a12 capital A22 plus a13 capital A23. Okay, then in such case the sum of this one is 0. Okay, so you can take either column elements or row elements, but if you are multiplying and multiplying sum of multiplications of element with different row cofactor, then you'll get 0. Okay, so let's do some exercise practice, and then we'll understand these concepts more. Okay, so simple 2 by 2 matrix is given. Okay, 2 minus 4 0 3. Okay, now what is the minor of 2? Only you have to leave this row, this column. So I'm left with only one element. So one element means determinant is same, right? So 3. Okay, for 2 minor is 3. So m 1 comma 1 is 3. Similarly, m 1 comma 2 is nothing but, for this element I have to leave this and this, I am left with only 0. So 0. m 2 comma 1 is this element, so I will leave this row, this column, so I am left with minus 4. Minus 4. m 2 comma 2, I leave this row, this column, so I am left with 2. Okay, these are my minors. Now go to the cofactors. Cofactors is same, value is same, but minus 1 whole to the power of 1 plus 1, which means even number, so this is same, plus 3. Okay, 0, you can put any value, but it will be minus 1 whole to the power of 1 plus 2, which is odd, so minus 1 minus, okay, 1 into 0, which is anyway 0. Okay, here you can easily understand. Okay, so minor of 2 comma 1 is minus 4, but minus 1 whole to the power of 2 plus 1 is 3, so that is odd, so you will get minus sign. Minus of minus 4 is plus 4. Okay, so this is a21 is plus 4. a22 will be, because it is even, sum of this I plus j is even, so you will have same value, which is plus 2. Hope you understand how to do this one for 2 by 2 matrix. Very simple. So you can do it yourself for others. Okay, and for 3 by 3 I'll take this example and explain how to do it. Okay, for this element a1 comma 1. Okay, first is minor. Minor is, I will leave this row, this column, so I'm left with 1 0 0 1, 1 0 0 1. Okay, this is my determinant, is my minor, which is nothing but 1. I know, right? 1 into 1 minus 0 by minus 0 into 0, which is 1. Okay, m 1 2 if I take, I have to leave this row, this column, so I'm left with 0 0 0 1, 0 0 0 1. Okay, which is nothing but 0. Determinant of this one is 0. Similarly, M13 which is 0, M21 which is 0. Okay. Now I have total 9 elements, right? I have to take M22 which is 1, M23 which is 0, M31 is 0, M32 is 0, M31 is 1. Okay. Now my cofactors are, basically I need to take sign in front, right? So M11 if I take, sorry, A11 if I take, this is M11 which is 1, and minus 1 whole to the power of even number which is 1, so it is 1. Okay. A12 minus 0, A13, okay, same 0, actually it is 0 only, anyway sign doesn't matter here. Okay. So similarly A21, A22, okay, A23 you can calculate for all. So this is how you calculate the minors and cofactors of a 3 by 3 matrix. Okay, hope you understand this one. Very simple. You can try yourself. Okay, don't make the mistake of sign. That is very very important. Okay, if you write 3 by 3, say I wrote actually 1, 2, 3 in a row, right? 3 by 3 matrix, I am finding the determinant. So very easily, if you make a mistake, very easily you will understand where the sign mistake has happened. Correct? So always you will have a odd sign here, 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 and here. Correct? So if I see here, this is odd sign, this is odd, this is odd, this is odd. This 4. Okay? So hope you understand what I'm trying to tell here. So you can follow same. You write cofactors 3 in a row for a 3 by 3 matrix. Then easily you can find out if there is a mistake. Next. Okay, same. You can do it yourself now. This one. Okay. First find the minors, then carefully put the sign in front and find the cofactors. Okay, using cofactors of elements of second row, evaluate determinant. Okay, you have to take cofactors of second row cofactors. Okay, and then find the determinant. Okay, first minors of second row. First we need to find out minor. So for 2, M21 is nothing but 2. So minor is, I have to leave this and this, 3821, which is minus 13. M22 is minus 3. M23 is 7. Now my cofactors are A21 which will be negative, minus of minus 13 which is 13. A22 is same, so minus 3. A23 is minus, yeah, A23 should be minus 7. Okay, this should be minus 7. Okay, yeah, minus 7. Now you find the determinant. I think this value is wrong now. Okay, so A21 into A2, capital A21 which is cofactor, A22 into multiply with its cofactor, A23 multiplied with its cofactor. So 2 into 13, okay, 0 into minus 3, 1 into minus 7 you should do. So 26 minus 7, 26 minus 7, that is 19. 19 is the answer, not 33. Okay, this is wrong. Okay, next. Now this one is, you have to find out the cofactors of third column and then evaluate delta. Third column is YZ, ZX and XY. Okay, so this is simple. If I take M13, this is M13 is nothing but 11YZ. Okay, this one, right? 11YZ, which is nothing but Z minus Y. M23 is Z minus X. M33 is Y minus X. Okay, now cofactors are M13 which is positive, so same Z minus Y. M23 is negative, so it will become Z minus X will become X minus Z actually. Okay, there will be a minus sign coming here. Okay, next. A33 is Y minus X, it will remain same. Okay, so now if you calculate A13 into, that is YZ into Z minus Y, ZX into X minus Z, because this is a minus sign here, right? X minus Z, and XY into Y minus X. Okay, so if you simplify, this is what you'll get. You can either leave it like that or you can simplify it and show it in a different way. It doesn't matter actually. Yeah, simplification doesn't matter here. Next. If delta is given this value, okay, delta of, I mean, determinant of this matrix, okay, A11 to A33, and Aij, capital Aj is cofactor of Aij, small aij, then value of determinant is equal to, okay, this is a multiple choice question, so just read the options carefully. First one, A11 into A31, cofactor of first element, okay, first row, first element, cofactor multiplied with cofactor of third row. Okay, so definitely it is not, but let's see what is the value. A11, A12, A13 and multiplied with A31, A32, A33 respectively, which means you will get actually 0. Determinant is 0. This value is 0. Sorry, it's not determinant, it's value 0. Because you are multiplying elements of one row with cofactors of another row. Right? So this is 0. Second one, A11 into A31, A12 into A21. So this here you will get some random value. Okay, this is not even 0 because all you have all random values. Okay. Third one, A21, A22, A23 and A11, A12, A13. This is again you will get 0 because you are multiplying elements of one row with cofactors of other row. Third one is A11 into A11, A12 plus A21 into A21 plus A31 into A31. So you took the first column multiplied with cofactors of the first column. So you will get this is the determinant. Okay. So option D is correct. Okay. Hope you understand how to do the minors and cofactors and then find the determinant of a matrix based on whatever row or column. Okay. Next. Let's get more close to the inverse of a matrix. Okay. So let us understand adjoint and inverse of a matrix both. Okay. Before understanding inverse, we need to understand adjoint, which is very simple. Okay. So adjoint matrix is nothing but transpose of a cofactor matrix. We know in the previous exercise and previous slides, we have seen how to make a cofactor matrix. Okay. Capital A, I, J. Correct. So once you know how to make that one, okay, now just transpose it, okay, then it is called adjoint matrix. And adjoint matrix is very important for a inverse of a matrix. Okay, there are two things which are important. Okay, determinant, which will determine if a matrix has the inverse or not, and adjoint matrix is the one which is we need to get actually to find the inverse of a matrix if determinant exists. Okay, let's understand this. Okay, for any square matrix, A into adjoint of A is equal to adjoint of A into A, okay, which is equal to determinant of A or modulus, right? Here we call determinant of A I. Okay. Once you know this one, okay. Now you apply A inverse on both sides. Basically, you will get adjoint of A equal to modulus of A into A inverse, and you take modulus of A to other side, you will get A inverse, right? That's all. This is here. Before coming here, inverse of a matrix is what is inverse? Inverse is denoted by A to the power of -1. We call it A inverse. Okay. Inverse of a matrix is defined as A into A inverse, which is equal to A inverse into A. Okay. Both should be true. This is very important. Okay. So if a inverse exists, this is true. Okay. It is either A into A inverse or A inverse into A. With both cases, it is equal to I, which is identity matrix of same order. Okay. Now from this above two, we can easily say that A inverse is nothing but adjoint of A divided by determinant of A. Okay. And from this, we can see clearly inverse exists only if determinant of A is not equal to 0. Correct. If determinant is equal to 0, it's called a singular matrix. Okay. Singular matrix don't have inverse. Okay. Only non-singular matrix have inverse. Okay. Note this. Let's get into chapter and do more practice actually. That way we'll understand these concepts more. Okay. Find the adjoint of each of the matrices. Okay, first one is 1, 2, 3, 4, which is very simple. Okay, we know how to find cofactor matrix. Okay, cofactor of 1 is 4, cofactor of 2 is -3, cofactor of 3 is -2, cofactor of 4 is 1. Correct? So once you know this one, you put them in the matrix form. Cofactor matrix is nothing but 4, 4 -2, -3, 1. Okay, now we need to transpose this. We need to transpose this. Okay, adjoint matrix is equal to transpose of cofactor matrix, which is nothing but 4 -2 -3 1. Okay, hope you understand how to get the adjoint matrix. Okay, and we know how to get the determinant. So these two are enough to find the inverse of a matrix. Yeah, next one is a 3 by 3 matrix, and it's almost the same way you will do. Only thing is you will have more cofactors to find first. Okay, then form the cofactor matrix. That's the only difference. So cofactors of A11 is nothing but I directly did the cofactors of each element, okay, without going to the minors actually, okay. So 1, for this one cofactor is 3, 3 minus 0, which is 3, and for this one, okay, it is 2 minus of -10, which is 12, and minus sign because it is A12, right, it's odd. I plus j is odd, so minus. So directly I have done here. So similarly, you should do for all the elements, and this is the cofactor matrix if you form it, and then transpose of this one is adjoint matrix of 3 by 3. Okay, so carefully see the difference here. Whatever is row, basically 3 minus 12 6 will be column. First row has become first column, second row has become second column, third row has become third column. Okay, so this is how we normally do the adjoint matrix. Okay, now verify A into adjoint of A equal to adjoint of A into A equal to determinant of A into I. Okay, this is what, based on this one, we proved that A inverse is nothing but adjoint of A by determinant of A. Correct? So let's prove this one. Just verify, basically, not prove. So you take a 2 by 2 matrix. This is very simple, right? Adjoint cofactors are -6, 4, -3, and 2. So my cofactor matrix is -6, 2, -6, 4, -3, 2. Okay. So my adjoint of A is transpose of this one, so this one, right? -6, -3, 4, 2. Now with this you will understand how you got the inverse of a 2 by 2 matrix. Actually, in the previous chapters or in the matrix chapter, we said 1 by AD minus BC. AD minus BC is nothing but determinant, and then D minus B minus C A, we said, right? So that is the adjoint matrix which you will get for a 2 by 2. Correct? So once you know this one, modulus of A is nothing but 2 into -6 minus of 3 into -4, okay, which is 0. Here modulus is 0, so this is a singular matrix. Actually, don't have inverse, but you can always find adjoint of this matrix, okay. So A into adjoint of A is nothing but you multiply A with adjoint of A, which is this one. You should get 0 because modulus is 0, modulus into I also 0, correct? So this is 0. If you find 2 into -6, -12, plus 3 into 4, 12. -12 plus 12, which is 0. So similarly, other elements also will get 0. And also you can check adjoint of A into A, which is same actually. You will get 0 again. So which is nothing but, since modulus is 0, modulus into I also 0. So we are verified this is true. Okay. Now for the same thing you verify for a 3 by 3 matrix. It is exactly same. You find the cofactors first. These are the cofactors. Cofactor matrix. Okay. Then adjoint matrix is nothing but transpose of cofactor matrix. You have it here. Then find the determinant. Determinant is simple. I am doing it by third row because there is 1 0 here. Or I can do it actually second column also. Okay. So which is 11. Okay. And my A into adjoint of A is multiplication of these two, which is 11i. If you see already, you can see it is 11i. Okay. Similarly, adjoint of A into A is also you get 11i. Okay. 11i is nothing but we know this is the 11 0 0 0 11 0 0 0 11. Okay. So we verified that this is true. Okay. We are not proved, but we verified. That's it. Okay. And this is the basis for getting A inverse. Okay. Next, find the inverse of the matrix if exists. Okay. So this is, we'll do a few of them, then others you can continue doing actually. Okay. So first thing is, this is a 2 by 2 matrix. You can do straightforward, but we'll follow the method that find the adjoint of A, and then determinant of A, and then divide. Okay. Determinant of A is nothing but 2 into 3 minus 2 into 4, which is 14. So inverse exists. Okay. You can find inverse only if it exists, right? So determinant is the first one to verify. Okay. Then cofactors are, these are my cofactors, cofactor matrix. Then adjoint matrix is transpose of cofactor matrix, which is 3, 2, -4, 2. Okay. Now my A inverse is nothing but adjoint of A by determinant of A, which is 1 by 14. Right. 14 is the determinant. 1 by 14. 3, 2, -4, 2, which is this value here. Okay. This is the inverse. So always once you have done this one, cross check multiplying this with A, you should get I. Okay. Identity matrix you should get 1 0 0 1. In case of 2 by 2 matrix, right? Cross check if there is anything going wrong, then cross check your calculations and then adjust it. Okay. Next. So another 2 by 2 matrix, you can do it yourself. Determinant is 13, so inverse exists. Cofactors, cofactor matrix, transpose of cofactor matrix, which is adjoint A. Then A inverse is nothing but adjoint of A by determinant of A, which is the value given here. Okay. Cross check with by multiplying it, you should get the identity matrix. Okay. Yeah. Next is 3 by 3 matrix, it's exactly same method we follow. Only thing is you have more number of elements to find the cofactors and do the rest of the things. Okay. So cofactors are here A11. I'll just we'll check one of them randomly. Okay. Just to make sure A21, let's take A21 is this value. Okay. A21 is 10, 2 into 5, 10 minus 3. Okay, so sorry, 10 minus 0, which is 10, and because it is a 2 1, sum of these two I plus j is odd, so you'll get minus, so minus 10. Okay, so this way you will find out the cofactors, and the determinant is I'm using third row because it has more zeros, correct? So which is nothing but if I take 5 into 1 into 2, which is 2, so 5 into 2, which is 10. 10 is the determinant, so inverse exists. Cofactor matrix is this one, adjoint matrix is the transpose of this one, okay, and then A inverse is adjoint by determinant of A, which is here, okay, 1 minus 1, 1 by 5, 0, 1 by 2, minus 2 by 5, 0, 0, 1 by 5, okay. So as I said, you need to multiply with A and cross check if it is coming, identity matrix is coming or not, okay. Next. So similar, exactly same, you just do it yourself, okay, and cross check the answer. Okay, so here also determinant is minus 3, so inverse exists. Then cofactor matrix, adjoint matrix is transpose of cofactor. Then A inverse adjoint by determinant. Okay, next. Same one. Okay, one more problem. So you do it yourself. Determinant is minus 1, so inverse exists. Cofactor matrix, transpose of it, which is adjoint A. Then A inverse is adjoint A by determinant of A. Okay. Yeah, another one. Only thing is the elements are trigonometric elements. That's it. Trigonometric numbers. So which is almost same. You don't see any difference. Only thing is wherever possible you will try to simplify it. Okay. So this is my cofactors. Okay. And then this is my inverse. I'll check the inverse. If I check the inverse, it is minus 1. So which means inverse exists. Okay. So if you see 1. Okay. 1 cos alpha into minus cos alpha minus cos square alpha minus sin square alpha, okay, which means minus, if I take common, it is cos square alpha plus sin square alpha, which is 1, so minus 1 is the determinant. Okay, determinant, so inverse exists. This is my cofactor matrix. Okay, this is my transpose of cofactor matrix, which is adjoint of A. Then A inverse is nothing but just a sign change basically, because it's minus 1. Determinant is minus 1, just a sign change. So this is my exactly actually same as A. Okay, so remember this. It's not always that A inverse will be different from A. It is possible that both are same also. Okay. So this is one such case which you are finding here. You may find many cases like this. Okay. You can cross check by multiplying and see. Okay. Next. Yeah. Let A equal to 2 by 2 matrix, B is a 2 by 2 matrix. Verify that AB whole inverse equal to B inverse into A inverse. Okay. So basically you need to find 3 inverse. Okay. So directly I'm writing ABCD inverse is nothing but 1 by AD minus BC. This is determinant. This is adjoint matrix. So I just want to directly use this one. Okay, D minus B minus C A. If AD minus BC is not equal to 0, that's it, condition. So directly if I use this, A inverse is nothing but this value. Okay, minus 9 by 2, 4, 7 by 2, minus 3. My AB is, sorry, this is A inverse is 5 minus 7 minus 2, 3. B inverse is this value. My AB is 67, 87, 47, and 61. And modulus of or determinant of A is nothing but minus 2. So my AB inverse is nothing but 1 by minus 2, and this value, which is this. Okay. So now all I need is basically, this is my AB inverse is already there. If I multiply B inverse into A inverse, I should get this value. Okay. So cross check B inverse into A inverse. If I cross check, I am getting same value. Okay. Which means AB whole inverse equal to B inverse into A inverse. This is verified. Okay. Next. Yeah, let A equal to 3, 1, minus 1, 2. Show that A square minus 5A plus 7I equal to 0. Hence, find A inverse. Okay. This is important. Hence, find A inverse means you should not follow the same procedure of finding the A inverse. We should use this equation to find the A inverse. Okay. So let's do this. How to do that? Find the A inverse. Okay. So A square, we know A into A. So this is my A square. Phi a is just a constant multiplied with each element of a. This is my 5a. This is 7i, 7001, 7007. Okay. Now all I need is a square minus 5a plus 7i, which is nothing but all zeros I got. Correct. So which means it is verified. It is verified that this is true. Okay. Now once you have this equation in hand, correct? You have this equation in hand, you multiply both sides with a inverse. What happens? Okay, multiply both sides with a inverse. What you will get is first term a square, a inverse into a square, which means a inverse and a will go off its identity. I into a is a. Okay, and in this case you will be left with minus 5 a inverse into a, which is I, so minus 5 I. Okay, in this case 7 into a inverse into I, which is a 7 into a inverse. Okay, now this is 0 because this side if you multiply with a inverse you still get 0 only. Okay, now from this a inverse is nothing but okay, 1 by 7th of phi I, you take phi I and a other side, so it will become phi I minus a, then 1 by 7, so 1 by 7 phi I minus a. This is my a inverse. Correct. So now you just calculate this one easily. You already have values of this, right? So a inverse is nothing but 1/7 of this is my phi I, okay, minus 1/7 of a, okay, which is if I do it I'll get 2 by 7 minus 1 by 7, 1 by 7, 3 by 7. Now you cross check, multiplying these two you will get 1001. So that means hence this is a inverse. Okay, so we have found a inverse not by the traditional method but from the equation. Okay, so this is another method, but who will decide this equation, right? Right, you need to get a equation here first and then apply on top of it. Next, so this is another problem exactly similar, only thing is they did not give the equation fully. We need to find a and b. Okay, so find a and b numbers. So simple, a square you can find easily because a is given, a square you can find. A into a is nothing but 3a, 2a, 1a, 1a. B into I is nothing but b, 0, 0b. Now you apply the equation, this should be equal to 0, right? So you get multiple equations. Okay, you cross check all the equations and find the values of a and b which will satisfy all these four equations. Okay, so 11 plus 3a plus b equal to 0, that is one equation. Or you can take simply here 8 plus 2a equal to 0, so a is minus 4. Okay, 4 plus a equal to 0, so a is minus 4, consistent. Okay, once you know a, you substitute here, you will get b value. Okay, a is minus 4, b is 1. You cross check, substituting in both equations you should get a 0. Okay, a and b. Okay, so a is minus 4, b is 1. Next. Okay, and now 3 by 3 matrix is given, a cube minus 6a square plus 5a plus 11i equal to 0, hence find a inverse. This is exactly similar to the previous problem. Only thing is the equation is bigger, you need to find a cube term here also. Okay, so first is a square. A square is nothing but a into a, so you will get this value here. Okay, now a cube you need, so a cube is a square into a, okay, which is this value. Now you have a cube, you have a cube, you have a square, you have a, you have I, 11i already. Okay, so what else you need? You just need to sum up the equation and cross check, you will get 0. So this is in fact this is a true valid equation. Once you know that this equation is valid, you multiply both sides with a inverse first, so you will get a square minus 6a plus 5a plus 11 a inverse equal to 0. From this I can find out my a inverse. A inverse is nothing but 1 by 11 of minus 5a plus 6a minus a square. So 1 by 11 of, okay, minus 5a plus 6a minus a square. So if you do all this, you will get a inverse, which is nothing but here. Okay, 1 by 11 I kept just outside, you can take it inside also. Okay, this is my a inverse. You cross check by multiplying. Okay, so for 2 by 2 matrix as well as 3 by 3 matrix, we can find some equation like this. Okay, from which you can find the a inverse. Next, same problem, different matrix is given, so you will do exactly similar way. First you find a square, a cube, then a cube minus 6a square plus 9a minus 4i, which is indeed zeros, so equation is valid. Okay, so you multiply with a inverse and then find out a inverse from the resultant equation. Okay, so this is my a inverse. Next, okay, let A be a non-singular matrix, which means determinant is not 0, of order 3 by 3, then adjoint of A is, okay, modulus of adjoint of A is. Okay, so this is a simple problem. You can take an example and try actually what is the value you get. but you can do it like this. Adjoint of A is nothing but this is one thing you should remember. Okay, modulus of or determinant of adjoint A is nothing but determinant of A to the power of n minus 1. Okay, n is the order, which means if it is 3 by 3, 3 order 3, then it will become determinant of A square of determinant of A. Okay, which means adjoint of A modulus is or determinant is equal to modulus of A square for n equal to 3. So the answer is B. Okay, you can remember this, or you can take any example one matrix, simple matrix, and then try. You will get the answer anyway. Okay, just take don't take all ones and all, because you don't know if it is, if you get one answer determinant as 1, then you don't know it is 1 square or 1 cube. Both are 1, right? So take some variety of numbers elements in. Next one is, if A is invertible matrix of order 2, then determinant of A inverse is equal to. Okay, so this you just take the definition of A inverse. Actually, A into A inverse equal to I. So if I apply determinant on both sides, basically determinant of A into determinant of A inverse should be equal to 1, correct? Which means determinant of A inverse should be 1 by determinant of A, correct? So answer is B. That's it. Okay. Okay, next. Yeah, next let's see one more application of matrices, actually, which is, this is the most useful thing when you go to higher order linear equations. Okay, polynomials and things like that. So this is called system of linear equations. How to solve the system of linear equations using matrices. Okay, so we know a consistent system. Okay, definition of consistent system is system of equations which to be consistent if solution exists. Okay, they are inconsistent if no solution exists. Okay, that's it. This is the simple definition of consistent system and inconsistent system. Now let's say there are equation like this: a1x plus b1y plus c1z equal to d1, then equation 2 and equation 3. You can represent this in the form of matrices like this. First you take all quotient of xyz, okay, in a matrix A. Okay, so you will get a 3 by 3. Then the variables in a matrix called xyz. Okay, it's a column matrix, and then the results, basically the RHS side into matrix B, another column matrix. Okay, which means if I do AX, okay, equal to B, I actually get the same three equations. Okay, so A1 into X plus B1 into Y plus C1 into Z equal to D1. Correct, same equation I'll get back. So I am representing in matrix form like this. Now if I say A inverse multiply with A inverse on both sides, okay, I'll get X equal to A inverse into B, right? So I got my variables xyz using this equation, and this is consistent only if A inverse exists, right? Okay, if A inverse exists, then I get the values of xyz. Okay, so that's why you have the definition of consistent system and inconsistent system. Okay, so now based on this one, we'll solve some problems and then understand this more. Okay, let's do the next exercise 4.5. Examine the consistency of the system of equations. Only consistency. Okay, so these are the two equations which is given. If I put in matrix form, A equal to 1 2 2 3, x equal to x comma xy, b equal to 2 and 3, right? Now this is consistent if A inverse exists. Correct, A inverse exists if determinant of A is not equal to 0. Correct, so check the A inverse. Determinant of A is 1 into 3 minus 2 into 2, which is minus 1, which is not equal to 0. So this is a consistent system. Okay, similarly second one, okay, you take the A value, matrix A, and then find out the determinant. If it is 3, so it is consistent system. Okay, next, another one. Okay, here also you take the A matrix A. Okay, determinant here is 0. Okay, so determinant 0 means you need to directly declare that this is a inconsistent system. You can also check maybe if xy are zeros, this equation has still a solution. Suppose it is not 5 comma 8, this is equal to 0, suppose, then x equal to 0, y equal to 0 is a solution for this system. Correct, so you can cross check that. If the determinant is 0, you cross check. Okay, you cross check simply by finding the adjoint of A into B. It should come 0. If it is 0, which means it is good, still you have a solution for this one. Okay, or Other way is you substitute x equal to 0, y equal to 0 and see whether it becomes the zeros. I mean, whether the equations are satisfied. Okay. So adjoint of A is nothing but 6 minus 3, correct? 6 D minus B minus C A. So 6 minus 3 minus 2, 1. Okay. Adjoint of A into B is nothing but 6 comma minus 2, which is not equal to 0, which means definitely there is no solution. This is the inconsistent system. Okay. So whenever you find the determinant as 0, then find out adjoint of A into B. It should not be it should be equal to 0, then it still has a solution. Okay, 0 0 is a solution. If it is not equal to 0, then we cannot tell anything. It's an inconsistent system. Okay, next. This is a 3 by 3 matrix. You will do exactly the same way. You have the matrix A, then find out the determinant. Determinant is A. Okay, now what is the meaning of this one? Which means if A is equal to 0, still determinant is 0. We'll say it is inconsistent. If A is not equal to 0, then it is. If A is not equal to 0, this system is consistent. If A is equal to 0, you need to still go ahead and find out adjoint of A into A, correct? So it is consistent only if A is not equal to 0. Okay, next. Yeah, another 3 by 3 matrix. Make the matrix A with all quotients of x, y, z. Okay, wherever x is not mentioned, that means quotient is 0, right? So now determinant of A, which is 0 here, which means we need to check adjoint of A into B. Or you substitute 0 0 0 and see. Okay, if I substitute 0 0 0, this should be 0, but this is 2, so it is definitely not consistent. 0 0, if I substitute, this should become 0, but it's not 0, so it is not consistent for sure. But you can find out your adjoint of A into B. Okay, so cofactors, then adjoint of A is the transposition of cofactor matrix. Then adjoint of A into B, which is minus 5, minus 3, minus 6, which is not equal to 0. So this is inconsistent. Next. Okay. So another three variable equations are given, three equations. So find out the matrix A, then find out the determinant of A, okay, which is 51, which means it is consistent. Solve the system of linear equations using the matrix method. Okay, two equations are given. This is a 2 by 2 matrix which you will form. So the method is same. The method is very simple. First you will form the matrix A, which is quotient of x and y in each row basically. Okay, each equation you will take in each row. Okay, so A is nothing but 5 2 7 3. X is the variable matrix, column matrix, which is xy here, only two variable matrix. B is the RHS side matrix, which is 4 and 5, which is also column matrix. Then we know that Ax equal to B or x equal to A inverse B. We need to find out A inverse. A inverse exists if determinant exists, correct? So first check the determinant. Determinant is 1, which means determinant exists. So A inverse exists. A inverse is nothing but 1 by determinant of A adjacent A. Okay. So which is nothing but 3 minus 2 minus 7 5. Okay. So this is my A inverse. So A inverse into B is nothing but 2 and minus 3. So x is 2. This is x actually. X equal to this value. So x is 2 and y equal to minus 3. You substitute and cross check if the answer is correct. Okay. So this is the way you will do, whether it is 2 by 2, 3 by 3, everything is same. Only thing is finding the inverse will be a little bit takes more time for a 3 by 3 matrix. That's all. Okay. And even if you want to go bigger systems, okay, 5 by 5 matrix, okay, equation with 5 variables, 10 variables, the matrix method is easy. This is the reason. Okay. So method is same basically. Okay. Next. So yeah, another two equations are given. You will do exactly same. You will form the matrix A, which is 2 minus 1 3 4, x is xy, b is minus 2 3, and then A inverse you will find out. Okay, so determinant of A is 11, so it exists. So A inverse is nothing but 4 by 11, 1 by 11, minus 3 by 11, and 2 by 11. So A inverse into B is nothing but minus 5 by 11, 12 by 11. Okay, so x is minus 5 by 11, y is 12 by 11. Okay, that's answer. Cross check it. Okay. Yeah, another 2 by 2, two variable equation is given. Okay, so linear equation. So you will do exactly same. You do it yourself and cross check the answer. The answer is x equal to minus 6 by 11, y equal to 19 by 11. Okay, another one, two variable linear equation. Okay, you can do it yourself. Okay, x is minus 1, y is 4. Now this is a 3 by 3 equation. Method is exactly same. Okay, we'll do it one problem. We'll do it. Only difference is yeah, matrix A is a 3 by 3 matrix, so you need to find inverse of a 3 by 3 matrix. Okay, that's it. So the three variable equation, I'll write it as 2, 1, 1. These are the coefficients of first equation, XYZ equation, coefficients. Second equation is 1 minus 2 minus 1, 1 minus 2 minus 1. Third equation is x quotient is 0, so 0, 3 minus 5. This is my A. My x is nothing but three variables are there. So in a column I write XYZ. B is nothing but RHS side, which is 1, 3 by 2 and 9. So method is same as I said, A into x equal to B and x is A inverse of B. So find out A inverse. Okay, first is determinant of A. I'm trying to find it by row 1. Okay, which is 26 plus 8, that is 34. Okay, 34 is the determinant, so which is non-zero, so A inverse exists. Cofactors are A11 is 13, A12 is 5, A13 is 3, A21 is 8, A22 is minus 10, A23 is minus 6, A31 is 1, A32 is 3, A33 is minus 5. Okay, this is the only thing which will take long time to find the inverse. Okay, otherwise procedure is exactly same. Now you have the cofactor matrix. So adjacent matrix is transformation of it, which is 13, 8, 1, 5, minus 10, 3, 3, minus 6, 5. Okay, now my A inverse is nothing but 1 by determinant of A, adjacent of A, which is nothing but 1 by 34. And this matrix here, adjacent matrix. So that is this. Okay, now x is nothing but A inverse into B, correct? So if I do multiplication, I did not do here, you will get 1 by 2 minus 3 by 2. Okay, so which means x equal to 1, y equal to 1 by 2, z equal to minus 3 by 2. You can substitute and cross check your answer. Okay, this is the method for 3 by 3 matrix or 3 variable linear equation. You will solve the using matrix method. Okay, so you will do exactly same for others also. Okay, another three variable system of linear equations are given. You will form the matrix A, X and B. X is nothing but A inverse B, so you will find the A inverse by using determinant and cofactors, then transformation to adjacent matrix, then find the inverse of A and then multiply with B. You will get X, which is nothing but 2 minus 1, 1. That means X is 2, Y is minus 1, Z is 1. Okay. So another equation is given, a three variable system of linear equations. Three equations are given. You will form the matrix A, X and B. Okay, X is nothing but A inverse B. Find out A inverse. Okay, and then multiply with B. Okay, this is my A inverse. Multiply with B. You will get X, which is 1, 2, minus 1, which means X is 1, Y is 2 and Z is minus 1. Okay. Yeah, another one. You can do it yourself. Cross check the answer here. Exactly same. No different. Okay. Find A inverse. Using A inverse, solve the system of equations, which is exactly what we are doing, just asked in a different way. Okay. So same thing. You'll solve it same way. Okay. Now this is a simple application question. Cost of 4 kg onion, 3 kg wheat, and 2 kg rice is rupees 60 combined. Okay. The cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. Cost of 6 kg onion, 3 kg wheat and 3 kg rice is 70. Find the cost of each item per kg by matrix method. Okay. First thing is write the equations. Let the cost of onion be x, cost of wheat is y, cost of rice is z. So my equation is 4x plus 3y plus 2z equal to 60. Right, 2x plus 4y plus 6z equal to 90 and 6x plus 2y plus 3z equal to 70. Now you put it in matrix form. A is 432, 246, 623, X is XYZ, B is 60, 90, 70 and you will do exactly same. So determinant is 50, cofactors are here. Okay, so you have your cofactor matrix, transform it, you will get adjacent matrix. Okay, the adjacent matrix is here, divide with the determinant of A, you will get A inverse. So my A inverse is nothing but 1 by 50, 0, minus 5, 10, 30, 0, minus 20, minus 20, 10, 10. Okay, multiply with B, which is 60, 90, 70, you will get XYZ, which is 5, 8 and 8. That means X is 5, Y is 8, Z is 8. Okay, so cost of onion is rupees 5 per kg, cost of wheat is rupees 8 per kg, cost of rice is rupees 8 per kg. This is how you actually transform the given problem into linear equation, system of linear equations. From that you transform into matrices, then find the inverse of the quotient matrix, multiply with the B, okay? Then that's it, you will get the answer, okay, of the variables. This is how you do. Yeah, let's do some miscellaneous exercises, okay? Different kind of questions here. Yeah, prove that the determinant given here in the matrix form is independent of theta. Okay, simply what you will do, you will find out the determinant first and see whether there is a theta term or not. Or if there is a theta term, you can simplify, okay, using trigonometric formula. That's it. So if I see the determinant here, okay, I'm doing the finding the determinant by row 1, okay. If I simplify it, what I'll get is exactly minus x cube, okay. I used only one trigonometric formula, which is sin squared theta plus cos squared theta equal to 1, okay. And then otherwise, I was taking common and then cancelling the same terms, similar terms, that's all, okay. So with this, I got the determinant as minus x cube, which is independent of theta. So that's what I proved. Next. Evaluate determinant of this given expression. Okay, it is a trigonometric expression. Most of the times you will get something like this only, because you need to apply matrices concepts as well as trigonometric formula to simplify it. Okay, so you take it. You can if you see there is a 0 here, so you can run the determinant by row 2. Okay, so minus sine alpha. Sorry, I did by column, third column. Okay, so minus sine alpha into, okay, sine alpha sine beta square minus, okay, and minus of sine alpha cos square beta, okay, then minus 0, so I don't need to do anything here, plus cos alpha is here, okay, which is 3 comma 3, so I'll get plus only, which is cos alpha cos square beta plus cos alpha sine square beta. Okay, now it is all about simplification. Okay, take the similar terms out. Okay, if I take sine square, sine alpha out, okay, this will become, if I take sine alpha out, minus into minus is plus. So sine square alpha is outside and inside is sine square beta plus cos square beta, which is 1. And from here also, if I take cos alpha out, it will become cos square alpha plus cos square alpha into cos square beta plus sine square beta, which is 1. So I am left with sine square alpha plus cos square beta, which is 1. So determinant is 1. Okay. Next. A inverse is given, B is given in matrix form, then find AB whole inverse. Okay, so either you can find first A, which is inverse of this one, then do A into B and then find inverse. Then you need to find 2 times inverse, correct? Simple wise, AB whole inverse is nothing but B inverse into A inverse, we know, reversal law, correct? AB whole inverse is B inverse into A inverse. A inverse is already there. I just need to find B inverse, that's all. Correct. So find B inverse. So this is my determinant of B, which is 1. So B inverse exists. Cofactors are here. Cofactor matrix is here. So adjacent adjacent matrix B, adjacent of matrix B is nothing but transformation here of cofactor, which is here. Okay. So B inverse is nothing but 3, 2, 6, 1, 1, 2, 2, 2, 5. Okay. So my B inverse into A inverse is 9 minus 3 5 minus 2 1 0 1 0 2. Okay, if A is a 3 by 3 matrix given here, verify that adjacent of A inverse equal to adjacent of A inverse and also inverse A inverse whole inverse equal to A. Okay, these two are two sets of problems here actually. So first thing is check what are the things you need to find out. You need to find out adjacent of A, let's call it B. Then B inverse you need to find. Then you need to find A inverse. Okay, then let's call it C, and then you need to find adjacent of C. Okay, then A inverse is C, right? So C inverse also you need, okay, which is almost you found the adjacent of C, so adjacent C inverse is pretty easy. Then rest all things you need to verify whether they are same or not. Okay, so just do carefully. You can write in a rough paper what are the things you require, first find them and then equate one by one. Okay. So my modulus of A is minus 5, cofactors of A are given here, transformation I got the adjacent of A, which is 14 minus 9 minus 1 minus 9 4 1 minus 1 1 minus 1, okay. And my A inverse is, A inverse also required, so my A inverse is this value here, okay. This is my A inverse. Now two things I did. Now third thing is, let's call adjacent of A as B, then find B inverse, okay. So this is the B, Okay, this is B. So my modulus of B is nothing but 25 here. Our modulus or determinant of B is 25. Cofactors are here. Transformation of cofactors, so adjacent of B, which is here. Then B inverse is nothing but minus 1 by 5, 1, 2, 1, 2, 3, 1, 1, 1, 5. This is here. Okay, this is my B inverse. That is adjacent of A inverse. I got it here. Now I have my A inverse. I need to find adjacent of A inverse. That's it. Okay. So let's call A inverse as C. Then adjacent of this one is nothing but adjacent of C is adjacent of A inverse, which is here. Okay, transformation of cofactors, which is minus 1 by 5, 1, 2, 1, 2, 3, 1, 1, 1, 5. Okay. Now if you see, this is exactly same as your B inverse. Correct? Both are same. Right? Which means we have proved the first part, adjacent of A whole inverse is equal to adjacent of A inverse. We did this. Now A inverse we have. Okay. Now A inverse, let's call it D. Okay. And D inverse is nothing but we need to find it here. Okay. So D inverse is adjacent of D transformation, cofactor transformation, which is here. This is the adjacent of D. And D inverse is nothing but 1, 2, 1, 2, 3, 1, 1, 1, 5. Okay. Which is, if you see, this is exactly A. Okay. So you can prove easily A inverse whole inverse equal to A. Okay. Next. Evaluate this expression. Okay, you can do normal method, find by determinant by row, by column, or anything you can find, but you can also do some little bit tricks here actually. If you see, there are some terms which are actually repeating here. You can cancel them easily. Okay, so first thing is I am doing R2 plus R3 to R1. Okay, so basically I am summing up R2 and R3 and adding it to R1. Okay, so which means I get in R1 what I'll get. Okay, R1 what I'll get is 2 times x plus y, 2 times x plus y, 2 times x plus y, which is all three same. And then R2 and R3 will remain same as is. Then I'm taking 2 times x plus y common. Okay, because from single row I'm taking, so it will come out. Okay, right? So this is 1, 1, 1, this one. Now this looks simple actually to find the determinant, right? Now also you can apply C2 equal to C2 minus C1 and C3 equal to C3 minus C1. Basically, I am subtracting C1 from C2 and C3. What I'll get? Let's see. I'll get two zeros because 1, 1, 1 is there. I'll substitute. Obviously, these two will become 0. So it's easy for me to find determinant. Okay. So 2 into x plus y, determinant of 1, 0, 0, y, x minus y, x plus y, minus x, which is very simple now. 2 times x plus y as is I wrote here. And this one is 1 into minus x square plus x minus y into y, which if I simplify, I get minus 2 times x cube plus y cube. This is the determinant. Okay. You can do directly also, you will get same, but just try to, I am trying to tell you how you can apply row additions, column additions, all that. So you can do it this way. Okay, next. Another problem. So here already 1, 1, 1 is there. So you do just column operations to make sure that 2 zeros you get first. Correct. Apply R1 equal to R1 minus R3. Okay. So I get this one because I have 1x same. So if I substitute, I get 2 zeros here. Correct. If I subtract, I get 2 zeros here. That's what I got here. Now I'm doing by only this row, by row 1 determinant I am finding. So minus x into x minus y. Okay, which is nothing but xy. That is a determinant. Right. Next. Solve the system of equations using matrices and determinants. Okay, if you see here, this is not a simple linear equation, but you don't need to worry. For you, 1 by x is a just variable. 1 by y is a variable. 1 by z is a variable. Correct. So in that case, your matrices looks like this. Okay, matrices of A into variable matrices, which is 1 by x, 1 by y, 1 by z, which is equal to B matrices 4, 1, 2. Ax equal to B, still it is valid. X is A inverse of B. So find out A inverse. This is your determinant, which is 1200. So A inverse exists. Cofactors, cofactor matrix, transformation, adjacent A you got. Adjacent A divided by determinant, which is A inverse. You got it. Okay, A inverse into B. And you got it, which is 1 by 2, 1 by 3 and 1 by 5. This is my 1 by x, 1 by y and 1 by z, correct? Which means x, y, z are 2, 3, 5, right? So you don't, if it is a linear equation, it is a difficult way of solving actually, right? It's not straightforward. But in this one, you have this advantage. So use that advantage. So this is your answer. Okay, next. Okay, XYZ are the non-real numbers. Then inverse of this one is, okay, inverse of this value. Okay, one thing is you can actually find out method all the way, but it is given in multiple options, right? This the question is multiple options. So how to solve when it is easily, okay? You just multiply. This is a very simple matrices actually. It's not a very sparse matrix. Most of them are zeros. So you just multiply with this one and see whether you get I 100 010 and 001. Okay, if not this one, it is easy. It's not so complex actually. So if you do that, option A is correct. Okay, that's it. That's the answer. Okay, next one is A is a trigonometric matrix. Okay, terms elements are trigonometric elements where theta is between 0 and 2 pi. Then determinant of A is between what? Okay, so this is simple. First find out the determinant of A. Determinant of A is here. By row 1 I am doing, I get 2 plus 2 sine square theta. We know that sine theta is between in the given range 0 to 2 pi. Sine theta is between actually -1 and 1, but sine square theta is between 0 and 1. Okay, sine square theta is between 0 and 1, which means if I substitute a minimum value 0 here, it is 2, maximum value is 1, then it is 4. So it is between 2 comma 4. Okay, so determinant of A is between 2 and 4 inclusive basically. Okay, this is the answer. Option D is the correct answer. Okay, so yeah, that's all. These are the all the NCERT chapter problems exercises in the book. Okay, hope you understand the underlying concepts of determinants and matrices completely. We'll start doing the determinants and matrices JEE and BITSAT questions and then practice problems. Okay, keep checking my playlist and the shorts actually daily shorts. Okay, thank you.